everyone, I hope this message finds you well. I'm thrilled to have the opportunity to present my topic in this video. We're going to delve into the fascinating topic about apportionment. I believe our discussion will not only be informative but also engaging. So without further ado, let's get started. Apportionment. Apportionment is a method used to distribute or allocate things among different groups or areas. It's a way of dividing up resources, representation, or responsibilities in a fair and equitable manner. Politics, for example, apportionment is used to distribute seats in a legislative body like the U.S. House of Representatives. Among the states, this is done based on population, so that each state gets a fair representation. Without apportionment, some states could end up with a disproportionate amount of power, while others could be underrepresented. In business, apportionment can be used to allocate cost, resources, or profits among different departments or projects. This can help ensure that each department or project gets the resources it needs, and that costs and profits are shared fairly. It can also help with budgeting and financial planning by providing a clear picture where resources are being used and where they are needed. So, in essence, apportionment is a tool for fairness and efficiency. It helps ensure that resources are distributed in a way that is proportional to need or contribution, and that everyone gets their fair share. It's a fundamental concept in many areas of life, from politics to business to everyday decision making. 5 methods in apportionment. Number 1 is Hamilton's method. Number 2, Jefferson's method. Number 3 is the Adams method. Number 4 is the Webster's method, and the last is Huntington Hill method. Hamilton's method. Named after Alexander Hamilton, this method involves assigning each state its natural number of seats. Its population divided by the total population multiplied by the total number of seats rounded down, and then distributing the remaining seats to the states with the largest fractional parts. This method was used in the U.S. from 1850 to 1900s, but it can sometimes result in the Alabama paradox, where a state loses seat when the total number of seats is increased. Alabama paradox is a phenomenon in apportionment, which is the process of distributing seats in a legislative body among administrative divisions entitled to representation. It was first observed in the United States during 1880 census when Alabama would have lost a seat in the House of Representatives if the total number of seats had been increased. Hamilton's method. This method is based on the population standard divisor and standard quota. The formula in getting standard divisor is SD equals to P over A, while getting the standard quota is SQ equals G over SD, which is our standard divisor. The standard quota is a whole number or the whole number part of the quotient of the population divided by the standard quota. Lower quota is the standard quota rounded down to a whole number. Upper quota is the standard quota rounded up to the next whole number. Before we proceed to the example, let us briefly discuss the Hamilton's rule. First one is we need to get the lower quota of the group. And then, the standard quota of the group with the highest decimal part is only rounded up to a whole number. If the sum of the lower quota is less than the value of A, the process repeated until the value of A is reached. In this example problem, Baliwasan Central School plans to assign 45 teachers to teach in a different grade level. The number of students in each grade level is given in the table. So we're going to use Hamilton's method to assign each grade level the appropriate number of teachers. In getting the standard divisor, we need to follow the formula of SD equals to P over A or P divided by A, where P stands for population divided by A, which is the required allocation. After getting the standard divisor, we need to get the standard quota of each grade level. So SQ equals to G over SD, where the G stands for the group or the number of students divided by the standard divisor. After all getting the standard quota, we will proceed in getting the lower quota of each grade level. Lower quota is the standard quota rounded down to a whole number. Basically, we'll get the whole numbers from the SQ, and that will be our lower quota. So the total of the lower quota is 41, it did not reach the required apportionment, so we will do the final apportionment by rounding up. The standard quota of a group with the highest decimal part is only rounded up to a whole number. So after we rounding up, we reach the required apportionment for each grade level. Jefferson's method, proposed by Thomas Jefferson. This method involves using a modified standard divisor instead of the exact population per representative to calculate each state's natural numbers of seats rounding down. The divisor is adjusted until the number of seats matches the desired total. This method tends to favor smaller states and was used in the US from 1790 to 1830. In Jefferson's method, we need to compute the standard divisor as the same way as Hamilton's method. Standard divisor SD equals P over A. Use a modified standard divisor which is arbitrarily chosen, must be lower than the standard divisor. By trial and error technique, obtain the required apportionment using the assumed modified standard divisor. We're going to use this example again, where we used Hamilton's method earlier. So in the Jefferson's method, we need to use a modified standard divisor which must be lower than the standard divisor. By trial and error technique, I come up with 16.77 as the modified standard divisor. In this example problem, Baluasan Central School plans to assign 45 teachers to teach in the different grade level. So we have the grade level, number of students, standard quota, lower quota, and the final apportionment. In getting the standard quota, we need to follow the formula of SQ equals to G over MSD. So, the G stands for the number of students, and the MSD is our modified standard divisor, which is I come up with 16.77 using trial and error technique. So, grade 1 is 120, divided by 16.77 is 7.15. Grade 2 is 105, divided by 16.77 is 6.26. So, we will continue this procedure to get the standard quota of each grade level. In lower quota, basically, we're just going to get the whole numbers from the standard quota, which is the 7, 6, 7, 5, 12, 8. The total number of it is 45. So, we're just going to copy it in the final apportionment because we already reached the 45 teachers. Adams method. Adams method divides all population by the modified standard divisor, then rounds the result up to the upper quota. Just like Jefferson's method, we keep on guessing modified divisor until the method assigns the correct number of seats. All the quotas are rounded up, so the standard divisor will give a sum that is too large. We're going to use this example again where we used the Hamilton's method and Jefferson's method earlier. So in the Adams method, we need to use a modified standard divisor which must be higher than the standard divisor. By trial and error technique, I come up with 18 as the modified standard divisor. Webster's method, named after Daniel Webster. This method is similar to Jefferson's method, but it involves rounding to the nearest whole number instead of always rounding down. This method tends to be more favorable to larger states. This method is like Jefferson's method, but the rules for rounding off numbers apply to the quotients. If the total number of rounded subquota is not equal to the number to be apportioned, a modified standard divisor is employed by trial and error. So we will use the same example earlier in the Hamilton method, but now we just need to round up the nearest whole number instead always rounding down. So in the rounded value, we're able to get the required apportionment for each grade level. Huntington-Hill method. This is a slightly more complex method that involves calculating a geometric mean, the square root of the product of the two numbers, for each state, and assigning seats based on these means. This method is currently used to apportion seats in the U.S. House of Representatives. Huntington-Hill method. Calculate the standard quotas, lower quotas, and upper quotas of each subgroups. Determine the geometric mean rounded to the two decimal places of each subgroup quotas and upper quotas. If the standard quota is less than the geometric mean, round down. If the standard quota is greater than or equal to the geometric mean, round up. If the sum of the rounded standard quotas equals the required A, we are done. Otherwise, choose an MSD or a modified standard divisor and repeat the process until the required number is achieved. In the realm of mathematics in the modern world, apportionment plays a significant role. It's a mathematical method used to distribute or allocate resources, seats in a legislative body, or other quantities in a fair and proportional manner. This concept is widely used in various fields, from politics to economics, and even in computer science for resource allocation. However, it's a complex process with many variables, and different apportionment methods can lead to different results. Therefore, it's crucial to choose the most appropriate method for each specific situation to ensure fairness and efficiency. In conclusion, apportionment is a powerful tool in modern mathematics, enabling us to make a fair and equitable decision in a complex world.
Hello, everybody. I hope everyone's having a good day so far. I'm Ayman Salidin from BSIT 1A, and I'm going to be your substitute professor slash teacher for today's video. And in our video, we're going to be talking about Introduction to Voting, which is a fairly simple, easy topic, but there are a lot of methods that we're going to be talking about. So let's go ahead and dive in. First thing is first, what exactly is voting? Well, it is the act or method of indicating a choice, an opinion, or a desire on a matter, such as selecting a candidate or by other recognized methods. For example, ballots. So here, before we go there, let's just unpin this and minimize the camera. Here are the voting methods that we're going to be talking about today. First off is the polarity method. Second is the polarity with elimination method, or what is also called an instant runoff method. Third, we're going to be talking about the border count method. And lastly, pairwise comparison method. Starting off with the polarity method, the polarity method is really simple. The process of it, basically the polarity method, the candidate with the most first place votes is the winner. The polarity does not necessarily mean the majority. All that matters is the first place votes. So, here's an example. BSIT 1A students are holding a section/class president election, and their four main candidates are Kaisal, Nadir, Anjanet, and Gurley. For short, let's just go with their initial letter, K and AG. The preference schedule for the class president's election is given below. So here it is. Now here, let's determine the polarity winner of the election. So here, with Kaisal, we have 18. With Gurley, we have 8. With Nadir, we have 4. And lastly, with Anjanet, we actually have 11 plus 3, which is 14. So, obviously from the numbers, we could see the highest one is Kaisal. She has 18. That means she is the winner. So K wins. Right? We are going to give a ranking for the candidates. Kaisal is going to be first. And then Anjanet with 14. And then Gurley, and lastly, Nadir. Does the polarity have a majority of the first place votes? Why or why not, right? So the answer here is no. Because if we add up all of these votes, we're going to end up with a total of 44 total. Now, to get the majority, we have to divide this by 2, which will turn out to be 22. That's 50%. Now, when we say majority, we're talking about more than 50%, which is 51%. So we're gonna have to round it up to 23. Now, this number, 23, is our majority. But with Kazel, we only have 18. But she's still the winner because that's how polarity method works. Doesn't matter if you have the majority of votes or not. Let's go ahead and give you guys another example. Let's go ahead and erase our writings here. All right. Zipsa's outstanding cheerleading teams receives an invite from 5 universities/colleges by the end of the semester. So they have our school has an outstanding cheerleading team, and they're invited to 5 universities to dance. But we can only choose one avenue to dance at. So our university made us vote for whichever we want to go to, right? So here is the election result. So we can see here for U, which is UZ, we have 49 votes, and then for Ateneo we have 48, and lastly for WIMSU we have 3. So the winner of the election here is obviously the highest in the first choice, which is U, or UZ. What other avenue looks very popular among the cheerleading teams? Ateneo is also very popular. So in the second choice, in the first choice they have 48 votes, but second choice they have 49 plus 3, which is 52. 52 plus 48 is 100. So we could see that it is very popular as well. So A here. And here the winner, it was UZ. Now, if we compare the number of votes of the avenue you stated in the question B, which is A, to those of each avenues, what do you notice? So like I said, what we notice is that just because UZ won doesn't mean that it has the majority of the votes. It won just because UZ was the first choice. And that is how polarity works. Next, we're going to be talking about polarity with elimination method, or what is also called IRV, or instant runoff method. All right, so with the polarity with elimination process, or IRV, here's how it works. Basically, essentially, it is the same as the polarity, but this time we're going to care about the majority of votes. So unlike polarity method, we only care about the first choice votes. Here we will also care about the majority rule. So if the first place voters or the winner doesn't have 50%, then we're gonna have to go to additional rounds until someone has more than 50% of the initial round. That's the difference between the polarity with elimination and polarity alone, right? So let's give you guys an example. Here, we have the same chart as earlier, or schedule. So here we could see we said that the winner is Kazel in the first choice voters, right? Because obviously that's the highest. But like we said, if we total this all up, total number of voters is 18 plus 11 plus 8 plus 4 plus 3 is 44. That's the total number of voters. Now, for us to get the majority, we said we're going to divide that by 2. Sorry about that. It's a bit long, isn't it? Which will have 22. And this whole number is the 50%, so we're going to round it off or round it up to 23. So 23 is the number that we're looking at for majority win. So Number of first place votes required for majority is 23. Now, polarity with elimination winner is going to be different than polarity alone, right? Polarity, case of 1. But here now, we're going to go ahead and start eliminating until we reach that majority. So, obviously, we're going to eliminate the least voted one. So, first one to go is actually not that. The first one to go is Nadir with 4 votes. Now, 4 votes goes to Girly. So here, Girly, let's write the chart. So we have K, A, G, N, A. K has 18, 14 for Anjanette, and Girly has 8, Nadir has 4, and that was a mistake right there. So this is the first chart that we have. Now, since we eliminated Nadir, like I said, his vote is going down to the next ballot, right? So that's Girly. So Girly gets Nadir's vote plus 4, which is 12. So now we're going to have a new chart. New chart is going to be K, A, and G. N has been eliminated. So now K has 18, Anjanette has 14, and G has 12. Now, we're still not there. We're still not at 23. So we're going to have to eliminate Girly this time because she is the lowest. So Girly is eliminated. So hers goes down to Anjanette. So Anjanette now, or 12 goes to 14, that is 26. So now Anjanette has more than the majority. She is the winner in this method. So here Anjanette won with 26. That is the difference between polarity and polarity with elimination. Let's go ahead and give you guys another example. All right. So here in this schedule that we have, let's go ahead and add up first the total number of voters. So we have 10 plus 5 plus 2 plus 1 plus 4 plus 4 equals. So 4, 4, 8, 9, 10, 11, 16, 16, and 10 is 26. Now, 26, if we divide it by 2 for majority, or to get the majority, that is going to be 13. But that whole number is 50%, and we need, like I said, more than 50% for majority. So the number that we're looking for is 14. Whoever has this is the winner with the most votes after the elimination. So number of the first place votes required for majority is basically 14. So if we look here, let's create a chart. A, you have A, B, the candidates, C, D, and E. First round, they have A has 10, B has 5, C has 2, 3, 3, D has 4, and E has 4. Now, since C has the lowest, we're going to have to eliminate C here, and the vote is going to A. So 2 of this goes to A, which A will have 12 now, and the other 1 would go to E. So now E has 5. So with the new chart, we're going to have A, B, and since C has been eliminated, C won't be appearing in this chart no more. So we're going to go to D and E. So now the new number that we're looking at, numbers are 12, 5, 4, and 5. Now, we still haven't reached 14, so now we're going to have to eliminate again. And this time we're going to eliminate D. That's because D has the lowest. Now, since C has been eliminated, we are not going to give it to C as well, but instead we're going to go ahead and give it to A. So 4 right here goes to A. Now we have 16, which is obviously more than half. And we have the polarity winner with elimination winner is candidate A. There we have it. So I hope you guys understood so far polarity and polarity with elimination method. Next, we're going to be talking about the board account method. Actually, before we jump to the board account method, let's talk about a con in polarity with elimination method, or the IRB, instant runoff method. So there is this thing that we call exhausted votes. So this is a problem. We might run into what they call an exhausted votes. These are the votes that may not count if all the candidates have been eliminated. So that's an issue. And another issue is as well, like with this method, some people might be able to manipulate their votes. So knowing that their second choice is probably going to win, they might do something with that. That's one of the cons, or those are the cons of polarity with elimination method. Now we can go ahead and talk about the board account method. Board account voting method. Board account is a voting method named after John Charles de Borda, who developed the system in 1770. In this method, points are assigned to candidates based on their ranking. So this time, the focus or main focus is based on ranking and not on the majority. Okay, so 1 point for the last place or last choice, 2 points for the second to the last choice, and so on. So this means basically if you have 4 candidates, first candidate or first choice is going to receive 4 points, second candidate is going to receive 3 points, third candidate is going to receive 2 points, and lastly, the fourth choice is going to receive 1 point. The point values for all ballots are totaled, and then the candidate with the largest point is the winner. So let's go ahead and give you guys an example. So here in this example, BSIT 1A is deciding where to celebrate or hang out during their sem break. The preference table is shown below. So S for Santa Cruz Island, M for the Falls, and G for Garden Orchid Hotel, L for LM Hotel and Resort. Here is our table. Now, like I said, first place is going to get 4 points, second 3, third place 2 points, and lastly, fourth place will get 1 point. So let's go ahead and find the winner under the board account method. Now, to find that out, here we're going to just transfer it to a bigger table and show it to you guys. So here we have the first choice, which we assigned, like I said, 4 points, second 3, third 2, fourth 1. So 12, for example, we're gonna multiply 12 by 4 in all of the first row choices, which here we're gonna have 48, 20, 16, and so on. And same thing happens here in the second row and third row and fourth row. So the total points that we have, so for Santa Cruz Island, for S, we have 36 plus 24 plus 12 plus 10 plus 20 plus 12, which is a total of 114. And then with the false, we have 20, 30, 8, 24, 18, and 6. Now if you all add that all up, that's 106. And then for garden orchid, we have 48, 15, 27, 12, 4, and lastly 10. So if we add all those up, we're going to have 116. And lastly, LM, we have 16 plus 40 plus 36 plus 18 plus 5 and plus 9. Total of 124. Under the board account method, LM Hotel and Resort is the winner because we have 124 points, so it's more than the others. Now, like I said, in the board account method, all that we care about is the total points and not the majority. Because if we're going to look at the majority, like let's say for the first choice, we could see that the winner is definitely not LM Hotel. But since we're going under the board account method, we're going to have to look at the points only. All right. So what is wrong with the board account? One potential flaw of the board account is a candidate could receive a majority of the first choice votes and still lose the election. So let's consider this schedule here below. So we have here first choice, right? And second, third. So here the first choice is going to receive 3 points, 2 points, and 1 point here on the third. Now, if we add up everything here in choice in A, so A has 9 plus 2. That is exactly 55%, which means it's the majority. And under the polarity with elimination method, this should be the winner. But obviously, in board account, that's not how it works. All that matter is the points. So we're gonna have to assign here. I'll show you guys with the one after. But here, if it's gonna be a majority, then the majority should, or A should win. All right, so here, like I said, assign 3 points. If we do the calculation and everything, we could see here that B won instead of A. Remember, A was the majority winner. So with the board account, B would win. This brings up another fairness criterion, which is majority criterion. Sorry. If a choice has a majority of first place votes, that choice should be the winner. So yeah, that's the issue with the board account, or the con. Next, we have lastly our pairwise comparison method, also called Copeland's method. Pairwise comparison method tries to satisfy the Condorcet criterion by looking at pairwise, or one-to-one comparisons. And it is also called Copeland's method. Now here's how it works. So basically each pair of candidates is compared using all preferences to determine which of the two is more preferred. The more preferred candidate is awarded 1 point. If there is a tie, each candidate is awarded half a point. After all the pairwise comparisons are made, the candidate with the most points, and therefore has the most pairwise wins, is declared the winner. Copeland's method is a Condorcet method. So let's go ahead and give you guys an example. In this example, Find the winner of this election under pairwise comparison, or Copeland's method. So we have 1, 2, 3, 4. We have 4 candidates, and with 4 candidates, there are always going to be 6 comparisons. No matter how you shuffle the candidates. So here, for example, A versus B, A versus C, A versus D, and then B versus C, B versus D, and lastly C versus D. Now, for me personally, when I start comparing, I just like to redo the table to make it look more neat and easier to look at. So, for example, A versus B. So here we are. We have 10 for A plus 11. And then we have 6 for B plus 15. So if we add them all up, we'll have A with 21 votes and B 21 votes. So this is a tie. Like we said earlier, if it's a tie, both of the comparisons will get half a point. So A gets half a point, B gets half a point as well. Now let's go to A versus C. A versus C, here we have A with 10 points and plus 11, like we said earlier. That's 21 plus 15. So now we have 36 for A. And then compare it to C, which only has 6 plus, or only 6 alone. So 36 votes to 6 votes. Here, A gets the point, or gets 1 point, because obviously A has more votes than 6. And C gets 0. Now, if we go to A versus D, we notice here D has 10 plus 6 plus 15. Ooh. And A only has 11. So A has 11 and D has 31 votes. So here in this case, D gets the point. Next we have B versus C. Same thing, if we add it all up, basically whoever has the highest votes gets a point, and if there is a tie, they both get half a point, and the lowest point will get 0 always. So let's go ahead and skip that. So in total, with 4 candidates, there are 6 comparisons, and here is the total points. Now if we add them all up, we have, with A we have half a point plus 1, that's 1.5 points. B has half point and 1 as well, so both of them get 1.5 points. C has 1 point only, or 1 win, and then D has 2 points. So 1 plus 1 is 2 points. So here the winner is candidate D. So notice that D is not a Condorcet winner. Copeland's method would pick the Condorcet winner if there was one. So now let's talk about what is a flaw or what's wrong with Copeland's method. Copeland's method satisfies the Condorcet criterion, majority criterion, and the monotonous, I can't say that word. However, Copeland's method is not perfect. Sometimes the Copeland method can violate the following fairness criterion. So this is the criterion that we're talking about that it might violate. So the dependence of irrelevant alternatives, or IAA criterion. If a non-winning choice is removed from the ballot, it should not change the winner of the election. Equivalently, if choice A is preferred over B, introducing or removing choice C should not cause B to be preferred over A. And that's it from me. I hope you guys have learned a lot of things, or whoever is watching this. I hope I did justice to introduction to voting. Next, I'll have two of my group mates, and yeah, Anjanette and Girly. That's it. Peace.
Hi, my name is Anjana Diaz, and let's talk about the weighted voting system. And now we're gonna talk about a weighted voting system. Ano nga bang weighted voting system? Minsan kasi may mga election na yung isang voters ay mas matimbang ang boto niya kaysa sa ibang voters. And ang ginagamit nating notation ay ang square brackets, diba? Pero minsan, pwede rin naman ang curly brackets pero madalas ang square bracket lang ginagamit. And the Q here is our quota. Ano ang quota? The quota must be over half the total weight. Example, kung ang total weight natin is 100, so half of it is 50. And then the quota should be 51, 52, 53, and so on. Basta huwag lalampas ng 100. And the weight here are the weight of every voters. Now here is an example. Company has four shareholders. Mr. Ryan has 35% ownership and Ms. Oliver has 20%. Mr. Perez has 31 and Mr. Gayan has 14. There is a motion to decide where best to invest their savings, and the company bylaws define the quota as 59%. So, para makapag-decide, kailangan ma-reach yung 59%. So, paano i-represent using the weighted voting system? Gawa lang tayo ng open square bracket, yung quota na 59, tapos, si Bayan ay 35, tapos si Olivares ay 20, tapos ang isa ay 31, and ang isa ay 14. So, ito ang notation natin ngayon. Yung first shareholder, ang weight niya ay 35. Tapos ito ay 20, 31, and 14. Siyempre, kung pipili tayo sino ang mananalo, siyempre siya yung over the quota. So, ibig sabihin, kapag si Mr. Abayon and Miss Oliveros ay nag-invest sila ng savings nila sa bangko, ang total weights nila ay 55. 55% lang. Means, kailangan pa nila ng isang boto. Pwedeng si third person or si fourth. Pero, hindi sa lahat ng pagkakataon valid ang notation natin na nilalagay. Dapat, nasusunod pa rin ang rules. Dapat ang quota ay tama. Kung mapapansin natin sa number 1, kung i-check natin ang valid and invalid na weighted voting system dito, dapat i-check muna natin ang mga sum ng mga weights. So, para makuha ang mga sum, i-add lang natin ang mga ito. 6 plus 7 plus 9 plus 3 and plus 1 is equals to 26. So, ang total weights natin ay 26. Half of it is 13. Eh kung 10 is less than 13, so yung quota is less than 13. Dapat kasi, ang quota is greater than 13 or pwede less than or equal to the total weights na 26. Ganyan. So, dapat ganyan. Pero dahil ang 10 ay di pasok sa range, so this is invalid. This number 1 is invalid for the weighted voting system. Sa number 2 naman, ang total weights natin is 7. Plus 1, plus 2, plus 3, and plus 1 divided by 2 is equals to 3.5. Yung total dapat is greater than 3.5 but less than and equal to sa pinakamataas na total which is the 7. So, ang 5 ay pasag sa range. So, this is valid. The number 2 is valid for the weighted voting system.
Hi, I am Girly Babes S. Oliveros from BS Infotech 1A. I will continue the discussion about weighted voting systems.
Turns to remember. First, coalition. Coalition, a set of voters, each who votes the same way, either for or against a resolution. Second, winning coalition. Winning coalition, a set of voters whose total vote is greater than or equal to the quota. And losing coalition. Losing coalition, a set of voters where total vote is less than the quota. Critical voter, a voter whose departure from the winning coalition makes it a losing coalition. Dictator, a voter who has a weight that is greater than or equal to the quota. And last, dummy, a voter who has no power and never a critical voter. If you want to know the number of possible coalition of n voters, this is the formula. 2 raised to n minus 1. N is the number of voters. Let's try our example. Given the weight voting system is 17, 2, 3, 5, 6, and 10. So what is the quota? Our quota in this given is 17. Number 2, how many voters are in the system? Starting number 2, the voters 1, voters 2, voters 3, voters 4, and voters 5. So voters are in the system is 5. What is the weight of voters V3? The weight of voters V3 is number 5. What is the weight of coalition V4 and V5? The weight of coalition of V4 is 6 and the V5 is 10. So 6 plus 10 equals 16. Is V1, V2, V3, and V4 is a winning coalition? So let's try this. Kapag inad natin yan, 2 plus 3 plus 5 plus 6 equals 16. 16 is less than 17. So hindi umabot sa quota. This is not a winning coalition. Which voters are the critical voters in the coalition? V3, V4, and V5. Is V3, V4, V5 is critical voters? So let's try if this is a winning coalition. 5 plus 6 plus 10 equals 21. So this is a winning coalition. For example, kapag inalis ko si V3, winning coalitions pa rin ba ito? Hindi na, dahil 6 plus 10 equals 16, and the quota is 17. So our V3 is a critical voters now. Let's try the 6. Kapag inalis ko ang 6, winning coalitions pa rin ba? 5 plus 10 equals 15. So hindi na. It means our V4 is a critical voters now. The same things sa V5. Magiging critical voters na din siya. Our last question, how many coalitions can be formed? Let's try our formula. 2 raised to n minus 1. Ang n natin ay 5, which means the numbers of voters. So 2 raised to 5 minus 1 equals 32, minus 1 equals 31. So we have 31 possible coalition. This is the end of our discussion about weighted voting system.